Section 7.1, our objective today is I can use properties of proportions. So a proportion is an equation of two ratios. So for instance, if I have the ratio A over B, if I set that equal to another ratio, C over D, then that is what we call a proportion. So that is one way to write a proportion. We could also write it as A is to B as C is to D. Okay, so that's another way that we could write the proportion. In a proportion, the first and last term are called the extremes, and the middle terms are called the means. Okay, so this is an extreme, this is an extreme, this is a mean, and this is a mean. Over here, the two outside ones are the extremes, and the middle ones are the means. Okay. And the properties of proportions are the following. Number one, the product of the means equals the product of the extremes. Okay, so in other words, if I have 2 over 3 equal to 4 over 6, then the property says 2 times 6 has to equal 3 times 4. Okay, so in elementary school and junior high school, you call that cross multiplying. Okay, but in geometry, we call it the property of means and extremes. Okay, so we'll use that phrase a lot, property of means and extremes. Okay. The second property, if you interchange the means, you get an equivalent proportion. Okay, so again, if I have 2 over 3 equals 4 over 6, then this property says I can write that as 2 over 4 equals 3 over 6. Okay, so the means can change places. Okay, property number 3. If you take the reciprocals of the ratios, the result is an equivalent proportion. Okay, so in other words, if I have 2 over 3 equals 4 over 6, then 3 over 2 has to equal 6 over 4. Okay, because that's so the reciprocal, and notice that the means and extremes still holds. So that's how you check that it's true, because the mean and extreme still has to hold. Okay, number 4, if you add 1 to both sides, you still have an equivalent ratio. Okay, so in other words, if I have 2 over 3 equals 4 over 6, and I add 3 over 3, and I add 6 over 6, that's going to give me 5 over 3 equals 10 over 6. And if I do means and extremes, I get 5 times 6 equals 3 times 10, which is 30 equals 30. So it still is a true proportion. And the last one is in an extended proportion. The ratio of the sums of all, or the sum I should say, of all the numerators to the sum of all denominators is equivalent to each of the original ratios. Okay. So here's what it's talking about. If I have the extended ratio 2 is to 3, as 4 is to 6, as 6 is to 9, then 2 plus 4 plus 6 over 3 plus 6 plus 9 when it's reduced still equals 2 over 3. Okay? All right. So let's look at some examples. So number 1, if x is to 4, as 3 is to 7, then 7x has to equal, so we multiply in the extremes, so it has to equal the product of the means, so 4 times 3. So 7x equals 12. Okay? And that is the property of means and extremes. Number 2, if 3 over x equals 5 over y, then x over y has to equal what? Okay? Well, notice that x moved over the y, so that means the 5 has to come under the 3. Okay? So that has 3 over 5. And that was the property of interchanging the means. Okay? And by the way, when we use these in a proof, for a reason, we would just say a property of proportions. Okay? Number 3. So if I have 3 over 4 equals x over y, is that equal to 3x equal 4y? Or is it 7 over 4 equals x plus y over y? So which one would be correct? Well, even if we exchange the means and the means here, and then we do means and extremes, this one would not be correct. Okay, it would have to be 3y equals 4x. So this one is not correct. Then for this one, if we add 1 to both sides, whoops. Okay, That gives us 7 over 4 equals x plus y over y. Okay? So this one would be the true statement. Okay? All right. Then, example 4. If I have the proportion 3 over x equals 2 over 5, I want to solve for x, or find the value of x. So I would use the properties of means and extremes. So I would say 3 times 5 equals 2 times x, or 15 equals 2x. Divide by 2, so x has to be 7.5. Okay. Number 5, if I have 3 over 5 equals 7 over x minus 1, the x minus 1 is a binomial, so we need to put that in parentheses. And if I want to solve for x, I'd use the property of means and extremes. So I have 3 times x minus 1 equals 5 times 7. Distribute the 3. So I have 3x minus 3 equals 35. Add 3 to both sides. So 3x equals 38. Divide by 3. So x equals 38 over 3. Okay. The other thing I forgot to mention is that you always, when you write a ratio, you always want to put your answer in lowest terms. Okay. And let's do one more example. So number 6. So number 6, I have triangle A, B, C. And I have bisector BD. So I know this angle is congruent to this angle. Okay. So if length of AD is to length of DC, as length of AB is to length of BC, and length of AC equals 18, length of AB equals 12, and length of BC equals 15. Find length of AD and length of DC. Okay. So let's let, whoops, this has to be D right here. Okay. All right, so let's mark what we know. We know AC is 18, and we know AB is 12. Okay, and we don't know AD. Okay, so we'll let that be X. So then DC, this one, can be represented by 18 minus X. Okay, and so and we also know that BC is 15. Okay, so let's fill in what we know. We know that AB, we know this ratio. So AB to BC would be 12 to 15. And we want to set that equal to AD to DC. So AD is X and DC is 18 minus X. And then we want to solve that. Okay, well, first of all, let's reduce this one so we don't have to use such big numbers. 3 divides both of those, so we get 4 over 5 equals x over 18 minus x. Okay? Do means and extremes, so we get 4 times 18 minus x equals 5x. Distribute the 4, so we get 72 minus 4x equals 5x. Add 4x to both sides. So we get 72 equals 9x. Divide by 9. So x equals 8. Okay, so x is 8, so length of AD equals 8. And length of DC is 18 minus 8, or